black one fell off.
Oh, yeah.
Why? It's so hard. Oh, yeah.
And back here you don't have like 200.
Happy birthday, everybody.
You're looking at finding the area of a prism, surface area of a prism. You have to find the area of each one of the faces and also the base. Okay? There are several different ways that you can go about finding the surface area of a prism, but probably the easiest one is to do what they gave you as an example on the sheets that I turned out to you. Each one of these sides, such as this, that I'm going over in black again, is called a lateral side.
So it's not the one on the other side?
Nope. Each one of these that I'm putting a dot in, and back here, would be called a lateral face. So this is a face, this is a face, this is a face, back here is a face. In this particular prism, there happens to be 4 of them, right? One here, back here, and in front. Those would be the lateral faces. The bottom part that's down here is called a base. The base here and the base up here are the same. That's what makes it a prism. Are exactly the same. They give you a formula that looks like the surface area or the lateral surface area. The lateral surface area would be these 4 things. The lateral surface area SA meaning surface area. One of the ways that you can find it in this particular prism is to find the surface area here, and how would you find the surface area of that particular rectangle? Length times width. How many of those do I have in this prism? 2 of them, one here and one back here, right? So I could find the area here, double it. I could find the area of this face and also double it, right?
Right.
Okay? They give you a formula that looks like this. pH. The P is equal to perimeter. The H is height. Okay? So if I wanted to find the lateral surface area, of this particular thing, I would have to find the perimeter of this and multiply it times the height of the box. Okay? If you can't remember how to do that, I would have to find the area here, the area here, the area here, and the area here, and add all those together. Which way do I prefer for a prism? Actually, I prefer finding the area of each one of the sides and adding them together. So if I had this little box, try and draw it again. If I knew this was 10,
We can't see it.
and this was 5, can I find the area of this part right here?
Yeah,
By doing what?
10 times 5.
Okay, so the surface area of this one would be 10 times 5, and don't I have another one exactly like that behind it? Times 2. Let's say this was 4. Can I find the surface area of this rectangle?
Yeah.
Add to that 4 times 5, and don't I have 2 of those?
Yeah.
We know that, but you know where to get it.
What else do I need to find?
Base.
Which would be this one down here.
Yep.
So that would be 10 times 4, and in this particular diagram I have 2 of them.
Okay, so why are we putting 2?
Because don't you have one down here and one up here that are exactly the same?
Okay.
That's why I'm doing 2 of them. If you look at a normal box, like the Kleenex box that's up at the front, or over here at the side, don't you have 2 matching of everything?
Yep.
That's why I had to multiply each one of those by 2. So if I wanted to find this total surface area, 10 times 5 was 50 times 2 would be 100, plus 4 times 5 is 20 times 2, which is 40, plus 10 times 4, which is 40, times 2, which is 80. So the total surface area would be 220, and if this was in meters, it'd be meters squared.
Mr. Norman, can we get it?
I guess so.
Okay, thank you.
Good luck. Oh, yeah, I'll need it. Got a little bit too much birthday cake. No cake? What cake we didn't get it? I don't know that you're... There now, don't forget about cake box and the cake.
The lateral area, is that square or is that square?
If it involves surface area, it has to be in square
Or
units.
no, lateral, like the lateral area, that's square.
Yep. Okay? They give you a formula that says surface area is equal to pH plus 2B. Which means find the perimeter of the base, multiply it times the height, and add to that the area of the bases, multiplied by 2. So with this same diagram, I have to find the perimeter of the bottom part, which means 10 plus 4 plus 10 plus 4. Multiply it times the height. Add to that 2 times the area of the base, and we'll worry about that in just a little bit. So what's 10 plus 10 plus 4 plus 4?
28.
How come you don't add it?
The perimeter. 140. Turn from perimeter to that area.
The big P means perimeter. So I take and find the perimeter, take it times, in this case, 20 or 5, which would give me a surface area of 5 times 28 is how much?
40.
Plus, now I need to find the area of the base. How can I find the area of the base?
10 times 4.
10 times 4. 10 times 4 is 40. Times 2 is 80. Total surface area of this whole diagram, 220 meters squared. Did I get the same answer?
Yes.
Would it always be that way, or did
Yes. Yes. It will be. Even as figures change, that's why they're giving you a formula such as this. When I'm finding perimeter of that base. What? Yes. Okay? So looking at the little sheet that you have there, they give you, as an example, find the lateral and surface area of the rectangular pentagonal prism above if each base has a perimeter of 75 centimeters and its height is 10 centimeters. They're saying that the base is a pentagon. Something similar to that. This is 15. That means this is 15. Means this is 15. Means this is 15. This is 15. Right? Okay, that means it's setting like this. It means that I have a prism that comes up off of this straight up, that it's going to have the same area here as it does above, right? So this is the base of it. Now if I wanted to find the surface area, I have to find the perimeter of the base, take it times the height. Add to that 2 times the base area. Well, can I find the perimeter of this particular item? How? 15 times 5. And they gave you a height of what? 10. Correct? That's just going to give you the lateral surface area. That means as this is extended up like this, that's going to be the area of this rectangle that comes up like this, the area of this rectangle, the area of this rectangle, the area of this rectangle, and the area of this rectangle. That's what the lateral surface area would be. How can I find the area of the base? Well, you just got done doing exercises in finding the area of this base over the last few days. First of all, to find the area of the base, don't I have to know the apothem? right?
Right.
And what else?
6 degree of this corner.
What else was with that formula to find the area in
Perimeter.
times the perimeter, right?
Mhm.
So to find the area of the base, I have A times P, but I'm still gonna have to find this A. How do I find that A? Remember, we completed a triangle,
Yeah, you have to find the degrees first.
and we're gonna have to find the degrees. How did I find the degrees?
Number of sides minus 2.
Times 780 and divided by 95.
So, number of sides is 5, 5 minus 2 is 3. 3 times 180 is 540. Divided by 5 is
108.
108. So what's going to be this degree measure right here? Be 54 degrees, wouldn't it? Number of sides was 5, 5 minus 2 is 3. 3 times 180 is 540, divided by 5 gives you 108 for the entire angle. Then I have to divide that by 2 because I just want this little part of that angle, which gives me 54. What's the length of the side from here to here on that triangle? 7.5. How can I find A?
54 equals A of the tangent of 54 over 54.
Okay, so the tangent of 54 degrees would equal A over 7.5. What's the tangent of 54 degrees?
1.376.
What?
1.376.
So what's the A going to equal?
10.32.
So can I complete this formula that's up here now?
Yeah.
Okay, so the surface area would equal 15 times 5 times 10 plus 2 times the apothem, which is 10.32, times the perimeter, which we have already found to be 15. So surface area, 5 times 15 is 75, times 10 is 750.
How's the perimeter 15 when the side, the length of that side is 15?
75, thank you. So what's 2 times 10.32 times 75?
1,548.
But this formula, if you check back, is supposed to have a half in it.
That's what I was saying.
So I still need to multiply it times 0.5. So it'd be 750 plus, what's 1548 times 0.5?
774.
So the total surface area,
1,550.
we'll just call it inches. Okay? Why do you need surface areas? Where do you ever use it?
Painting,
Mainly in painting, right? Covering something,
wallpapering,
wallpapering,
wrapping presents.
wrapping presents. Yep.
Yeah, dang.
Yeah, she's just full of ideas.